A trapezoid is a shape that, I don't feel like that's going to let me type very much. So it is a quadrilateral, so that means four-sided figure that has one set of parallel sides. So just one, so not two, just one set of parallel sides. So a trapezoid could, most often when we, well, that was very much not straight. Let me grab a line tool here. So usually when we think of trapezoids, we think of a shape that looks something like this. So it has the top and the bottom that are parallel, right? If I could extend these, they would never touch, but then the sides would end up intersecting. Usually that's what we think of when we think of a trapezoid, but a trapezoid could also be a right trapezoid, and it could look like that, and it could have a right angle and still just have the top and bottom bases be parallel. And it could also, you know, be drawn on its side, and it could have the sides could actually be the ones that are parallel to each other. And so, right, it could look something like that, and so the sides would be the parallel part. So a trapezoid just has one set of parallel sides. So four-sided figure, one set of parallel sides. So go ahead and draw me 3 trapezoids there. So how do trapezoids relate to a parallelogram? So if you figured out from the hands-on one, when I get 2 of these trapezoids, it actually, and we flip one, it's actually going to create that parallelogram. So 2 equal trapezoids are going to make a parallelogram. So 2 trapezoids that are the same make that parallelogram. So I do have to flip one. So one thing to notice, right, if this is base 1, this right here is the same as this right here, base 1. And if this is base 2, this is the same as this. So in order to get the entire base of the parallelogram, I do have to put base 1 and base 2 together to find that. So parallelograms, if I take a parallelogram and I make a diagonal cut, I end up with 2 trapezoids. So not from corner to corner, that's going to make a triangle, but just a slanted cut, I guess I should say a slanted cut, is going to give me 2 trapezoids there. So our formula here, so what we want to do is we have these bases here. It's like I looked at before, right? Here's base 1 and it matches down here. And then base 2 is here on the bottom, is matching here. So in order to find the area of a parallelogram, we would do base times height. Well, in order to find this base of the whole parallelogram, I have to take my base here and I have to add on the base here. To find that base, I've got to do some adding first. So we need to take base 1 and we need to add on base 2. And I want to do that very first. So we're going to put that in parentheses. We want to do that first. Now we know the base. Now I can multiply by the height. Right? The height of this trapezoid is the same height as this parallelogram. So I can just multiply by the height. But once I did that, that was a base and a height. That gave me that entire parallelogram, that whole entire thing. So to get it back to just the trapezoid, what are we going to do? Just kind of like a triangle. To get it back to just the trapezoid, we want to cut it in half. So again, you can either take 1/2 of this, right? 1/2 of the base plus base times the height, or I can take this and cut it in half. Timesing by 1/2, dividing by 2 are going to give us the same thing. So to get our bases, we have to add them to find that entire base of the parallelogram, times by the height. So this is parallelogram, but then I want to get it back to just the trapezoid, cut it in half. So let's try a few of these here using our formula. So we can see base 1 is 4 and base 2 is 6. So I need to do 4 plus 6, and then my height is here. It's connecting the two bases is 5, so I'm going to multiply by 5, and then I have to cut it back in half. So I need to add first, since it's in that group's following order of operations. 4 plus 6 is 10, times 5 is 50. I cut 50 in half, like 50 cents, 2/4, cut it in half, would be 25 cents or 25 inches, and it's still squared because I'm still just finding two dimensions, the base and the height. So yes, I'm cutting it in half, but I'm still just multiplying base times height. So let's try another one here. So we can see, right, this one is tipped on its side. So we need to find the bases. The bases are what are parallel. So I can see the bases are here, and it really doesn't matter what I say is base 1 and what is base 2 because of that commutative property. I can switch those. So I need to add 2.5 plus 4.5 as my bases. So there's 10, 6, 7 with a decimal. So my bases together are 7. And I'm going to times that by the height, right? The height is connecting those, 5.2. And then I will cut that in half. Because right here, right, I added on that 2.5 base. The height's the same, and then here's my 4.5. This really just made a rectangle. So I've got to cut it back in half to get back to my trapezoid. So 5.2 times 7, so go ahead and do that with me. So 2 times 7 is 14. 35 plus 1 is 36, and I have 1 decimal place. That makes sense. 7 times 5 is 35. My answer is just a little bit bigger than 35. That helps me know where my decimal should go. Now, that was base times height. That's the entire rectangle is 36.4. So now we need to cut that in half to get back to our trapezoid. So here we have 1. We have 1 left over, and it goes in there 8 times. And bringing down the 4, decimal up, goes in there 2 times. So this area is, 18 and 2/10 meters squared. So every time we've got to square them, because we did base times height, 2 dimensions. Okay, so go ahead, make sure you have your notes filled out about how to find the area of a trapezoid.